Right, in this video I'm going to quickly go over the Year 13 IB Physics. It's the higher level relativity section of the Part 2, but all of the standard level questions are in this as well. There's just some additional ones. Okay, so skip ahead to the first question. One of the postulates of special relativity states that the laws of physics are the same in all inertial reference frames. State what is meant by inertial in this context. Well, inertial in this case just means not accelerating. Remember that for all of the rules of special relativity to apply, we need a reference frame that is not accelerating. An observer is traveling at a velocity v towards a light source. Determine the value the observer would measure for the speed of light emitted by the source according to Maxwell's theory. Well, Maxwell's theory was the new theory. That was the theory that where he derived all of the equations to describe electromagnetism, and that predicted that electromagnetic waves should always travel at speed c. So the answer is C. We can write here as well that that's 3.00 times 10 to the 8 meters per second. Okay, and then according to the Galilean transformation, well, that's the one where he says we have to add the speed of the source or the speed of the observer to the speed of light. So here we have an observer traveling at velocity v towards the light source. That means that they should measure the speed of the light plus their own speed. So c plus v. Okay, two protons are moving with the same velocity in a particle accelerator. Observer X is at rest relative to the accelerator. Observer Y is at rest relative to the protons. Okay, so for X, who is at rest relative to the accelerator, both protons are moving. So each one, if they're both moving, that means that each one will be producing a magnetic field around them, because they are like a current, and that means that the other one will be moving through the other proton's magnetic field, which means it will experience a magnetic force. So both protons are moving, so each is moving through the other's magnetic field. They both experience a magnetic force. Okay, they both also experience an electrostatic force due to their charge. Okay, for Y, Y is moving along with the protons, and so for Y there's no magnetic force because there's no motion. The protons aren't moving relative to Y. So the protons are not moving relative to Y. So the only force observed is due to electrostatic repulsion. Of course, both have to observe the same laws of physics, so they should vertically move in the same way relative to each other. And so the forces, the vertical forces, should really be equal. This can be explained. We don't need to do that for these 4 marks, but we can explain it. So because the 2 charges are moving to the right, so this charge is moving this way, we can use it's a positive charge, so we can use the right-hand grip rule to determine that the field must be going like this. Which means that this bottom charge here is moving to the right through a field that is going to be into the page there. And we can use the Fleming rule or the slap rule then to determine, using our right hand, that the force that it's going to experience is going to be upwards. So FB, if we call this one proton 2, FB on proton 2 is up. B here stands for magnetic. A B is the symbol for magnetic field strength. So the force on proton 2 is going to be upwards, the magnetic force. The electric force, the electrostatic force, well, it's 2 positive charges, so it's going to be repulsive, so it's going to be downwards. So the electric force on P2 is down. What this means is, in the other case, there's only an electric force. And so this means that the electric force in this situation has to be bigger than it is in the situation as observed by Y. So this is all as observed by X. For Y, it's going to be just an FE on P2 down. Okay, so how do we explain the fact that the electric force for X is bigger than the electric force for Y? Well, they're both moving relative to X, which means that they will be length contracted, which means that there will be more charge per unit length, which means that the charge, so basically for X, the protons will look like this, with all the charge concentrated in a much smaller area, whereas for Y, the protons will have this shape, and so the charge will be spread out more. Because the charge is concentrated over a smaller area for Y, for this one, it means that there'll be a stronger force acting on those protons, so the electric force will be a little bit bigger. That last part of the argument, explaining why Fe is bigger than when it's moving as opposed to when it's standing still, is not really required for these 4 marks. All you need to do is explain why there's an electric and magnetic force for X, and why there's only an electric force for Y.